Good morning, good afternoon, and good evening, depending on where you are. We would like to give you a warm welcome to today's webinar, which explores the issues facing the 21st century automotive manufacturer. My name is Christine Durkin, and I am your webinar organizer for the day. This webinar is scheduled for an hour, and we will be answering questions at the end. Throughout the webinar, please do send in your questions via your GoToWebinar control panel, and we will collate for our team of experts to address at the end. I would now like to introduce some company introductions and presenters for the day. For today's webinar, we are delighted to be supported by Omron, a world leader in automation and safety solutions. Its wide portfolio of products, comprising advanced electronic and electromechanical components and systems, enhance vehicle safety and reliability, as well as comfort and convenience for automakers around the world. And now a bit about UBsense. We're a leader in enterprise location intelligence solutions and work with some of the largest automotive, aerospace, and heavy vehicle manufacturers in the world. Installed at hundreds of sites around the globe, our enterprise software platform, SmartSpace, handles the complexity of location, enabling manufacturers to fully exploit the industrial Internet of Things and drive Industry 4.0. Our solutions are proven to drive quality, reduce costs, manage complexity, and increase productivity across operations. And now to introduce you to our presenters. Firstly, for those of you who have read the Lean Thinking article from Advanced Manufacturing, Monica Menarkin, the Automotive Market Manager at Omron, was the panel moderator at this event and has over 10 years in the automotive industry. Thank you, Monica, for joining us today. The article is available from your control panel, as are other handouts for you to take away. Next, I would like to introduce Adrian Jennings, our resident RTLS expert, also on the Lean Thinking panel. He serves as VP of RTLS Technology for UBsense. And thank you, Adrian, for your time today. And finally, I would like to introduce our Head of Product for Indoor Location-Based Systems, John Heathcote, who will be moderating today. So, without further ado, I will hand over to John as moderator of the session. John, thank you.
Okay, thanks for that, Christine. So I'm going to kick us off with a bit of an intro to get us started on the discussion today. I'm sure everybody from the auto industry will agree that there are some key trends that are driving the shape of the auto industry today. So, for example, we're seeing significant increases in customization options that consumers can choose from in the vehicles that we buy today. In fact, some OEMs allow you to go onto their website and fully customize every part of the vehicle that you're buying from them. Other things like cost cutting and globalization of manufacturing is driving OEMs to consolidate assembly processes into a smaller number of plants. And yet, at the same time, they're trying to build multiple different platforms all on the same line. And with all that, they've also got customers expecting more and more for their money. So cars are getting more and more complicated. And they want new stuff more and more frequently than ever before in those cars that they're buying. So this is driving an ever-increasing number of parts and processes required to build modern consumer vehicles. And it means that OEMs are required to invest in line refits and to stay competitive in this changing landscape. So Monica, I guess my first question to you is, why is, with all these changes that are required, why is it currently so eye-wateringly expensive for OEMs to make these changes to their lines?
Thanks, John. I like to put it a different way. How many times have you decided to take a detour on your way to get somewhere because you knew you'd hit traffic, and based on your past experience, you thought you'd have a better chance of arriving on time if you took an alternate route? Or you second-guessed the GPS because you know that computers are only as smart as their programming. What I'd like to say really with that analogy is that companies are constantly facing this challenge right now, particularly in the automotive space, on how to manage the tension between the predictive part and the human nature part. And so with that, you really need to think about the long game. And what's clear to me and clear to many historians that have looked at the entire route of automotive manufacturing since the third industrial revolution is that truly innovative technologies take a long time till they gain widespread use. And according to an MIT study in 2016, the average is between 10 to 25 years. And I think what's happened is, in order to buckle that or take that all in, what we tend to see an arrangement come about that's really in the form of a cost avoidance project. Manufacturing is very capital intensive in this space. And so what's happening is they're not necessarily enhancing any profitability per se, but arguably preventing profitability from deteriorating or just being the last step that you look at before you send the car out the door. And too many of these projects lead to a capital portfolio with a very high headline level of returns without much improvement in the bottom line. And, an involved finance team, they can examine the wisdom of deferring the cost, say, to replacing a pump, you know what I mean, and saying, well, should we replace the system and stuff like that? But people are truly not looking at the long game or the bigger picture. And so what I think needs to happen to make these changes is people need to start looking at how they review returns on a project. So it's not only just the capital expenditure that you have to look at, but really look at how the capital returns work. And maybe the business case needs to be made on a 3, a 6, an 18-month level, right? And really look at how that's evaluated. And to really place a role on the original sponsor of that project to have accountability for that outcome. Did we really make a profit here? So I think that needs to change. And until that changes, I think the construct here is that mines are going to be super expensive.
Okay, so that's a really, really interesting perspective, Monica. Adrian, I wondered, from your perspective, what do you think are some of the reasons things are so expensive in the current state of play?
So I think for all the reasons Monica said, that an assembly line is an inherently expensive thing. It's a complex beast. It requires a lot of planning, a lot of design. There's some very expensive systems in there. So the question is really, why is it? Not so much why is a line so expensive, but why is it repeatedly so expensive to keep refitting and redesigning them? And my view on that really is about how the lines are designed, and that is to produce largely a particular model. Every time we see a model refit, we see a very large investment in line refit to accommodate that new model. And what we've done is kind of leaned out these lines. We've over, 100 years of doing this, really learned how to optimize an assembly line. But what we do is, having optimized them, created a high degree of brittleness. The lines are very brittle in lots of different ways. And one of the ways that a line is brittle is it's brilliantly optimized to build one thing, but you try to build something significantly different, and it just doesn't work. There's no leeway or flexibility in there. So when you change what you're building, new model, new platform, it's a new line. And in making these lines as fabulously optimal as we have to execute the job at hand, I think that has caused a continuing reinvestment in those lines to re-optimize them for the new task at hand every time there's a change. And that really adds to the total lifetime cost of a plant from end to end.
So that sounds to me, from what I'm hearing, is that there's a tendency, let's call it lean, to optimize discrete parts of the process. But that in itself might actually be part of the problem in the overall cost of refitting these lines. Monica, do you have an opinion on that?
Yes, and I think I'm going to be a bit controversial with this comment, but basically I strongly believe, at least in the current constructs, Lean, Six Sigma, and Agile, and those like kind of constructs around that type of lean manufacturing need to die. And I'm going to clarify that point by saying these constructs were invented way before the advent of many of the Internet of Things technologies came out there, or even the idea of Internet of Things. And the 90s and 80s are essentially over. And so despite massive investments that we've made in management time and money and innovation using these constructs seems to remain, for most, a very frustrating pursuit. And a strategy is nothing more than a commitment to a set of coherent and mutually reinforcing policies or behaviors aimed at within an organization, clarify objectives and priorities, and help focus efforts around them. The fact is that companies regularly define their overall business strategy, their scope, and their positioning, and specifically how various functions or departments function within them, how they will support that. But one of the things that I've learned during my years kind of consulting is that I've found that firms rarely articulate strategies to align with their innovation efforts within their business strategies. And so without an innovation strategy, without that leap of how you're going to put all this stuff together, right, you can't, all you get is kind of like this grab bag of best practices. And so I'm not going to say that any of these practices per se, like lean, is bad. The problem is that an organization's capacity for innovation stems from an innovation system. They have to look at it as a whole, not a limited place where Adrian had mentioned, the lines have become brittle in spots. And so it really has to encompass the whole system. And really what you need is a coherent set of interdependent processes and structures that dictates how the assembly line or the company searches for novel problems and then forms solutions to those problems. And then you get that synthesization of ideas into a business concept and product designs, manufacturing designs. And then you can select truly which projects get funded out there.
Okay, great. I mean, what I'm hearing you say, Monica, is really key for us to take a system-wide view of building cars in the future, and that means that in moving from a mass market to a mass customization focused world, we instead of optimizing the line for a single purpose, we're now trying to, I guess, optimize the line for multiple purposes, but we still need to build at a global scale, and that means global volumes. So Adrian, would you say that I guess traditional lean thinking is actually limiting our ability to build cars, to be more flexible and respond to changes faster?
Yeah, I mean, I take what Monica says. I mean, Lean, Six Sigma, the time is for those to die, and I suspect that is actually in the process of happening. Lean and Six Sigma and those kinds of activities have been very atomic in their approach, I should say. If you optimize each piece of a system, then the system itself is optimal. And that's not always the case. You might optimize this piece of the system here at the expense of a different part of the system over there. And actually, stepping back a little bit and zooming out, you might have had a different strategy if you were optimizing the whole thing. And a typical example might be you can lean out your parts supply chain to the point where you have absolute minimal WIP inventory in parts supply. And that means you probably have a very, very small amount of parts on hand, but it makes you incredibly vulnerable to parts shortages and makes you vulnerable to line stoppage. So, if the line stops, how much does that cost you versus carrying maybe a little bit more WIP inventory in the parts on the front end and optimizing a bigger system? And you can step back and zoom out even more to the point where you're taking this much grander end-to-end approach to what is the thing that we're optimizing. It's not a set of individual processes. It's one big meta process from end to end. And I guess I wanted to say as well, Monica brought up, the way we manufacture and assemble vehicles these days was invented long before the technologies that we have available to us. And it's always kind of fun to ponder what might Mozart have composed if we sat him down in front of a Mac and gave him Pro Tools. And equally, what might Ransom Olds and Henry Ford have developed in terms of mass manufacture of vehicles if we'd sat them down today and said, look, here are all these technologies. So we do have to take a long look at the way we've been doing things and think about whether those are the right ways to continue to do things.
Excellent.
And John,
yeah, go ahead.
If I was to add something, maybe another corollary to the whole argument is that if you have an organization that only, let's say, we'll take a customer service rep, because that's pretty easy for everybody to manage or imagine, that handles several calls per day. If you applied lean into that situation, you might overlook the value of an employee who is capable of winning over an agitated customer. Consider also the use of workload scheduling software for maintenance employees, right? These systems increase overall operational efficiency and employee performance, measured as the number of service calls perhaps completed. But what happens is the system doesn't account for the complexity inherent in the different jobs. And here comes into that mass customization issue. What happens is you get high-performing experts are penalized for taking on complex assignments. And that also starts to formalize the line. The line gets broken down into millions and millions of very simplified tasks, right? As you lose what makes each person's contribution unique in that sense there, and that duality is not always apparent. And what I like to say is that operational knowledge and skill in applying those metrics has not kept up with the organization's ability to create them. And we have to figure that out if we're going to be able to embrace that mass market and mass customization on that scale.
So that's really interesting that you say that, right? Because if we truly believe that this is where the industry's going, my experience is that a lot of what we're saying might be quite hard for the industry to swallow. It's quite steeped in tradition. So Monica, what do you think are actually the barriers to getting OEMs to start thinking like this, thinking differently?
I think the big thing is tradition. We have a strong tradition, and the fact is, a car is truly a miracle of engineering. I mean, we put 45,000 plus parts, and we assemble them together, and we expect that vehicle to drive off at the end of the line. I mean, that is truly, truly amazing. But we also kind of have to look at some of the statistics with that. We think about risk aversion. Yes, that vehicle could potentially, harm somebody. So the other thing is that we have to look at, how much time are we wasted looking at, let's say, the bad data coming out of the line or the inability to do that. And somebody told me that 50% of an average, worker's time is held in idle. It's kind of like when we look at the data that these folks are collecting from all these vehicles also, everybody's into this big data phase. 50% of those search queries in 2016 were over 4 words or longer, and they're only getting larger. So while we're getting more information, we seem to be doing less with it. And so I think what needs to happen here is that along with the better data that we're getting through these IoT technologies, should we start to get implement them in. We need to develop a more nuanced view of human qualities and human potential within the line, and how maybe AI and other IoT technologies fit in with that. And so it may be that we can not only accept but embrace some of the behaviors that might not be reducible to quantifiable metrics. And I don't think there's any amount of data that can fully capture all of performance qualities on a line. And some may argue with that. I think in a world that is increasingly driven by quantitative analyses of employees and performance in manufacturing, we need to find ways to efficiently incorporate both the quantitative and the qualitative aspects of performance and how to maximize those. And so until we start to do that, I think that's going to be really tough to get people to look at things differently.
Adrian, do you have anything to add to that?
In terms of barriers to innovation, I think there are some quite stiff cultural barriers to changing the way things are done in automotive assembly, and I don't think they're even particularly conscious. There are things that we do that we simply have forgotten are things that we probably could do without. So let's think of a few examples. Quality inspection. Why does quality inspection even exist in a plant? It exists because there are just some processes on the line that you can't guarantee are going to be perfect, and therefore you have to check them. You can't guarantee that a door is going to hang exactly right. Somebody's going to check the door shuts on in an inspection process and make adjustments if they have to. To the extent that you could get rid of those imperfections in process, you could completely get rid of any quality inspections. But when we design an assembly line, does anybody really think of not provisioning floor space for quality inspections? I would hazard that the answer is no. That there are certain processes, assembly lines, there's quality inspection, there's repair and rework, and those things are just parts of a plant. Well, they don't have to be. And similarly, there are, cultural, there's cultural stickiness, is a nice way to say it, around the notion of a fixed workspace. Some OEMs are quite flexible in the way they handle a workspace. The majority, I would say, are extremely, almost ideologically connected with the notion of a fixed workspace. And again, that absolutely is what made the mass production of vehicles possible in the first place, but doesn't have to be that way. So I think there's a strong, invisible cultural attachment to, in capital, with capital letters here, the way things are. And that is the way things have been. And only a few looking outside that box thinking, well, do we really need to do it this way? So I think that's a big barrier, a cultural barrier.
So that's all about looking forward and not necessarily being wedded to the traditions of the past. And one of the
and I think recognizing when you are kind of connected to the traditions of the past, a lot of it feels like this is just the way it's done, without stepping back and thinking, why do we do that actually? Why do we have inspections? It's a band-aid, right?
Indeed. And I mean, if we're on the traditional mindsets topic as well, I mean, one of the things that's truly fixed in most plants is the physical space you've got to work with, and you've already touched on this. So, I mean, for example, I remember seeing just recently a really interesting article on Automotive News about Tesla, where Elon Musk was describing how the Fremont factory is actually bursting at the seams. So, okay, space is really key. So how do you well, how does optimizing the way you use your physical space influence the way you go about building the factory of the future? I mean, Monica, do you have an opinion on that?
Yeah, and so that's a very interesting article and a very interesting thought. So let's talk about that a little bit, the Tesla example, where they typically employ cellular manufacturing. So customers demand a variety and customization as well as specific quantities delivered at specific times. No one's going to argue with me about that, about how the automotive industry is working today. So if you're a lean producer, you have to remain as flexible as possible in order to serve your customers' needs, right? So cellular manufacturing, is one of those concepts that came along with lean that really allows companies to provide their customers with the right product at the right time, that whole idea of just in time. And it does this by grouping similar products into families that can be processed on the same equipment in the same sequence. And then to successfully maintain one-piece flow in that manufacturing line or cell, the traditional conveyor through, you have to employ a quick changeover technique. So when you think about cellular manufacturing in that set, you have to accept a number of facts or kind of constraints on your process. The first thing is that if you want to use cellular manufacturing in that construct, you have to be able to support a high ratio of setup to processing time. You also have to make sure that demand is stable, so predictive analytics becomes very, very important to you. Another thing that you have to kind of enforce is that work has a unidirectional flow, which means it's going in one direction only, right? And then the last one is that there's a significant delay in moving parts between the departments. And so that frames up the ideal environment for cellular manufacturing. But if you accept that ideal environment, right, then you have to also accept that you must invest in monitoring and analysis. So all those quality inspections that Adrian talked about earlier. You also have to invest in a lot of people and a lot of stations in order to make that happen. And this typically requires more people and more capital. And then the last one is that you have to set up pretty rigid functional barriers. What I mean by this is that when you have something in a cellular layout like that, right, any breakdown or any stoppage has enormous consequences. Another limitation of this approach is that you need very high volumes, and it is very difficult to insert a product into the stream. So in addition to the more space and the more people, it becomes you have to do it right the first time, right? So imagine when you're setting up your line, right? You can think about it. If you have to do something the right time, you're going to put all those checks and all those processes into making sure that it doesn't leave the station. And so I think that's kind of really influenced the physical space. But what we're really finding right now is that maybe that's not the way to go. And I think right now people are starting to experiment, at least with the fact that maybe it's okay if something goes up the line and comes back down, or maybe goes into a separate station to be worked on. And so I think this physical constraint of how we think about a manufacturing line has to change. Adrian, do you have any thoughts on that?
I have lots of thoughts on this actually. So let me.
I know.
let me talk about a few things, and John, if you want to drill down, then that's fine. But space is just such a critical resource that it's hard to make any more of. And it's very different thinking about a plant, say somewhere in the Midwest in the U.S., which actually does have space around it. versus a plant in the middle of Munich, which, you're not pushing the walls out. There's a street right outside. So, space is very limited and more in demand, right? Because every time we add bells and whistles and gadgets and gadgets to cars, we're adding processes, and processes have to happen somewhere. And the more and more processes you put on a vehicle, the more and more space you need to assemble them. And now you start peering at your parts storage and thinking, gosh, can we cut that down because now we have no place to keep parts on hand? Or you start to unhappily look at your repair department and say, gosh, that cost overhead department there, that's all about rework and not really any value added processing. What about that space over there? So there's, I think, a lot of angst around space. And what I see anyway, I'm in and out of a lot of plants, is at some point you're jamming so many processes into such small space that you start to have process density issues, and you just have too many people. I think one study anyway that I read was a study on what is the optimum number of people to have in a workspace on an assembly line, and I think the conclusion of that study was about 2.2 people. It's hard to deploy 0.2 of a person, but 2 people is about a good number before you start running into congestion and ergonomic and potentially even safety issues. So you can't just jam more people in to get these processes done. So what are you going to do about space? And it kind of brings us full circle back to this notion of one of the defining characteristics of how space is utilized in almost every plant you go in, not every, but almost every plant you go in, is this fixed assembly line, this fixed moving line, this constant speed, chain-driven, multiple segment, maybe even multiple speed, but nevertheless, series of continuously moving assembly line segments that dominate the space planning in a plant. And, Monica talks about cellular manufacturing, and absolutely that is a different and potentially better, albeit with risk, better way to utilize space. But if you forget about cellular and just talk about the macro concept of what would an assembly process look like if you broke away from the fixed moving conveyor, it gives you all kinds of flexibility and options. So I would definitely, and I know we've got time to delve into more questions on this, but I would definitely see a movement away from the fixed conveyor.
So I was going to jump in there and ask you if you've got examples of, if you move away from the fixed conveyor, how could OEMs take advantage of that? What are new ways they could manage processes in space if they do that?
Yeah, okay, so let me give you a couple of ideas. I mean, I don't think these are specific examples. You see a little bit of this, but let's just talk about some ideas. Let's talk about repair. I've talked about rework a little bit here. Let's say you get a stripped thread on a sunroof bolt, and you can't repair it in station, and that error now flows off the line. And what's our strategy today? Our strategy today is finish building the car, put a ship hold on it, throw it out into repair. Let's get the headliner ripped out and the sunroof repaired, and put back together and get that car shipped. Well, why? That's a costly way to make that repair, and the reason is it's a lot cheaper to do that than try and take that car out of process and fix it and reinsert it where it came out, right? And why is it so hard to get the car out of process? Well, because it's on the train, it's on the moving conveyor. It's hanging on a clamshell carrier attached to a train drive in the roof, right? So you can't pull it off. And sure enough, there are certainly places where you can pull cars off lines and people provision that, but it's rare. Most of the time, an issue like that flows off the line and gets repaired off the line. So that's a great example. What if you could just take a car and have it independently conveyed, right? Let's not even talk about how. We'll get to it. But what if it could just say, hey, that didn't work. Instead of stopping the line, fixing it in place, instead of scrambling to fix it on the line or letting it run off the line, let's just pull that vehicle out, to a side station. Let's not have Monica talked about this, the cost in a cellular model of moving product from one place to another. Why can't we repair that guy right where it came off the line, push it back in? We've got to manage the resequencing, but break away from that paradigm. Another simple example would be, let's say I'm building a platform and one has an electric powertrain and one has a conventional, internal combustion powertrain. Well, hey, why don't we have a couple of parallel line segments? We don't have to batch the cars up. We don't have to have a workstation that's optimized for doing both kinds of powertrain or two different lines. Why does the assembly line not split into parallel paths for a short period? For highly congested processes, why can't we run a couple of workstations in parallel and have them reconverge afterwards? But I mean, I go on, and I'll let Monica talk, but breaking away from this linear thinking and this, once you're on the train, you're on it till the final destination station, there's all kinds of things you can do to optimize the flow. And maybe that wasn't optimal when you were building black Model T Fords, but when things get to this level of complexity, you've got to, again, step back and look at what is the thing I'm trying to optimize here. And it's the full system. So it may be more expensive to build two parallel drivetrain lines, but ultimately, does that give you better flow and improve your overall throughput? I mean, that's a question to answer.
So I think the other thing that we need to look at really is that we have to stop being a slave to takt time as we see it in these fixed workstations. And we have to start thinking about eliminating time as a factor. Because I strongly believe in the future, it is going to be the most precious commodity out there.
Yeah, can I jump in there just real quick, John, and talk about takt time? Because I guarantee you there isn't a plant in the world that you can't walk into and ask anybody what takt time is. It's such a fundamental concept within the plant that it's just a given that everybody knows it, but it's also just a fundamental given that there is one, that there is a notion of a time period during which any process must be completed. And you see that breaking in lots of different ways. You see offline options processes that happen after the assembly line because they're happening, they're too long to fit in the takt time. But you also see, Monica, you talked about this, you see idle time. I mean, you see workers on an assembly line who are sitting waiting for their vehicle to index into a workstation so they can start to work. I've sat in plants watching people with a fastener in a socket head ready to spin, watching the line side display till the VIN number pops up and says, hey, you've indexed into your workstation, you can start. Your takt time starts now, boom. That's waste. It's also waste if that person gets a cross thread, has to back it out, go back in again, and doesn't quite get the process finished, but for two turns of the torque wrench, hit a line stop controller, and now you've got a little 20-second micro stop of the line while the supervisor runs down and gets it going again, or for the want of two more turns of the fastener, right? So why do we have these fixed workstations? And the technology is there today to get away from that. You don't have to have that. This is one of those things. If you'd have said to Henry Ford, hey, don't worry about the takt time and the moving assembly line and breaking everything up into these chunks, we can create virtual workstations. We know how to locate things in the plant. We know how to geofence. We know how to tell you which vehicles are where and which tool is where. We can give you workstations that grow and shrink. We can give the guy 2 more seconds to get his last 2 turns here. We can ask that girl we can let her start a little bit early because she was finished and she's ready, and why not give her the space? We can change that workstation size per model, per option, and per any other thing that's happening at that particular moment that means that the fixed takt time is not the optimal thing in this particular situation, right? So we just have an enormous degree of flexibility, and I'm glad you brought it up, Monica, that takt time is one of those examples of the things that we just assume we're going to have in the plant.
Excellent. So, I mean, I know we're coming up to the end of our time, and some really interesting kind of themes and topics have come up here. I mean, we've covered everything from how you optimize lines and how you increase flexibility in the face of variable demand and this mass customization topic, how we better use our people, how we better use our space, and the data that we're generating about our lines. That sounds to me a lot like what we hear on a day-to-day basis in terms of industry trends around Industry 4.0, Internet of Things, and even big data. So, I mean, from this picture that we've been painting today, how do you, Monica, feel what we've been talking about fits into those big mega trends that are happening in industry?
So it really has to do with the definition of, versus machine to machine versus Internet of Everything. I mean, automotive manufacturing plants were the first, to start employing like data historians and collecting that type of data and really working on machine to machine level items. But the thing to remember about machine to machine is it focuses only on specific processes or silos, and it typically prefers common protocols and common components, and it's historically followed, and there's no changes that aren't, hence predicted. But when you really start to talk about the Internet of Things and Industry 4.0, or even the Internet of Everything, as Cisco coined, the focus moves more from an applications to the concept of spaces. So think about an assembly line as spaces instead. And so a space is something that prefers diversity and avoids silos. It requires a different type of investment. And also, the Internet of Things, IoE type space, and M2M communications have remote device access in common. That's about where the similarities end. And though M2M solutions offer remote access to machine data, the data is traditionally targeted or point solutions in service management applications. So something that you would see at the end, to track, I produce this vehicle. It's not really giving you that operational view. So rarely, if ever, is the data really integrated with the enterprise application to help overall improve performance. And really, that integration of device and sensor data with big data and the analytics and the other type of applications as we bring those components from the floor up, right, is really that core concept behind the Internet of Things and IoE. And it's that integration along with the human interface that is going to be key to achieving those benefits throughout the manufacturing enterprise and ultimately growth in the end.
Excellent. It's interesting that you bring up the human element. Adrian, I mean, do you have an opinion on how this all fits together? And I mean, ultimately, a lot of this is still about people. Where does that all fit together?
Yes, absolutely. I think that's a critical piece, and it also links back to how do you get started here. How you get started in Industry 4.0 or the factory of the future is not getting rid of all your people and buying a bunch of robots and completely automating the entire plant. We know that's not a single step or necessarily even the ultimate conclusion. What we need to do immediately is help people do their jobs better. And those people are all the way from the line workers themselves up through team leaders and supervisors and department managers and all the way through the organization. And a big part of how you help people do their jobs better is, number one, give them the controls and freedoms to help them cope with issues. You give them the proactive visibility that you can to help them make better decisions on the fly. And you free them from constraints which are causing them to work a little bit suboptimally. So I think the people part is pretty critical, and I'd agree with Monica. There's a lot of machine-to-machine thinking when you think about these big concepts. But for me, for my money, and from the Ubisense perspective, in terms of what we do as well, it's just really all focused on process controls and visibility that help people execute better in the demanding environment of an assembly plant today.
Guys, I think that's a really good note to finish on. I think there's been a lot of ground covered there. Some really interesting and some somewhat controversial topics. I know we've been collecting questions from everybody who's signed in, and I'd like to hand over to everybody who's on the call. I think Christine will be able to submit some of those questions so we can continue the debate for a little bit longer.
Well, thank you, John, Monica and Adrian. That was really good. We have received some questions from our audience, and for the audience, if we do run out of time, of course, we'll provide the answers and circulate to you all. So the first question I have here, excuse me, sorry. There was an article in Design Engineering today about Nissan aiming to edge out competition. Did you see it? And is this what you mean when you say lean is dying?
I think that, at least from what I'm seeing, it's a sign of the times. I think people are recognizing that if they subject, lean has very much been focused on point-to-point processes. And if the process is really ugly, no matter how many different ways you try to make that process nice and clean, the end result is that it's really a non-functioning process. So as we start to think about the new technologies that are out there with like IoT, and we start to think about the new capabilities we have, maybe programming a robot off a cell phone instead of using a teach pendant, or an iPad or something like that. You have to start to think that there's different ways of doing things. So why are we constraining ourselves? Why are we throwing IoT at something that's kind of ugly? I think the article is really interesting because at the end of the article, there's some points there about the culture of lean. And I think that's, going back to my previous conversation with Adrian, really is that, that human element is still very important. And one of the things that lean has traditionally done is, created ownership and pride over that particular workspace for that, that optimization. I do feel that there is potential for that to remain, in this new construct. It needs to be modified. Adrian, do you have anything to add?
So I think let me throw in a little anecdote from a completely adjacent or non-adjacent, in fact, industry. One of the places Ubisense does work is in helping public transit companies manage their transit yards, keeping track of buses in the yards. And traditionally, they have paper records, and a guy walks around the yard and writes down the numbers of buses on this schematic map. And everybody works off this written record of where buses are in order to manage things like scheduling and dispatch and so forth. And we're going in there, adding automated tracking systems, beautiful maps, business rules and business logic to help them automate the process. And one of the very first times we did this, they came back to us and said, gosh, that's really great, but could you also create a schematic map like the one we use and make a version that we can print out so we can use that? And that's just a perfect example of taking an existing process, throwing a technology at it to try to make it better, but ultimately making a very tiny incremental improvement. Okay, the map was a bit more accurate and a bit more repeatable, but it wasn't very real time because it was printed out. So the Nissan article is really interesting because they're saying, everybody should have a look at that, because what they're saying is every time we take the existing process and polish it a little bit more, we're getting incremental improvements, 5% here and 10% there, but it's not good enough for us. We have a goal to make multiplicative improvements in how we're doing. We want things to be twice as good and 3 times as good, and you don't get that just by throwing technology at processes. And this gets to just a whole topic of technology adoption. It is not okay to, it is not a solution to simply invest in technology to improve your processes. Technology is simply an enabler to support a process change plan. And I think that's what the Nissan article is about. They've said we're going to change the way we do things.
Well, that's great. Well, thank you very much, Monica and Adrian. We have another question relating to the topic of the webinar today. And it says, all this is very interesting, but we solved these issues already. Are we learning anything new here?
So let me go first on that one, Monica, if you don't mind. I just, because that's great and commendable, actually, but extremely rare. And sure enough, there are OEMs out there, or not even OEMs, but individual plants within an OEM that are out on the cutting edge. There are certainly OEMs that, as part of their brand, identify themselves as, taking the lead in every respect in the industry, including the way that cars are designed and built. But that's the 5% of early adopters. The majority of plants you go in are, I'm not going to say behind, because I think there's a mass of people that are all in the same place and a few that are ahead, but there's a whole mass of OEMs and plants who are struggling to cope with some of these issues of complexity and variability on the line, and are actually a little bit overwhelmed with this notion of IoT, Industry 4.0, factory of the future. There's a lot of buzz around that. And I've met more than one senior executive in an automotive OEM who's been anointed the keeper of IoT within the company. You, sir, are anointed with the role of introducing Industry 4.0 into our processes. And I've had more than one conversation where they've looked at me across the desk and said, what do we do? What does it mean? And so, I think there are people that have solved these problems. Precious few. The majority are struggling to figure out how to make the next step.
That's great, Adrian. Thank you. Another one here. These are big changes. How do you start down that road without introducing unacceptable risk in the production process?
Monica, I'll let you answer that one.
Okay, so I think the first thing to recognize is that innovating is really, really hard, okay? And so I think it has to start with a few good leaders. They have to be able to navigate that tension. And what I have found in teams that haven't been so successful with these technology adoptions is that the leaders actually give up, right? And they don't hold their team accountable for growing. I mean, the whole part about innovation is really change. Change is scary, right? But if you don't hold, your stakeholders and other folks out there accountable for growing, it's not going to work. It's not going to work. And what I typically see is they themselves back off on it. So what happens is that the people actually deprioritize innovation. Instead, they promote just kind of, let's just try to keep the status quo, right? We didn't really innovate, but it's still running. I think it's also important to kind of stick around a while. Too many times I see stakeholders, not sticking around long enough for that project to be really realized. There's many different aspects. It's not just the capital investment that actually, makes an IoT investment work, right? We finally have machine learning out there, right? Big data is already out there. You know what I mean? Hadoop, right? Already $10 billion industry. I think, to have stakeholders that can actually measure a return qualitatively and quantitatively, in a 3, 6, 18, 36-month period, is really, really the way that we start to innovate. It has to be constant touch points. And then if we fail, we have to look carefully at why we fail. We can't just abandon. Failure is a great place where you get to learn what not to do next, or to learn how to do better the next time. And I think failing early and often is, you know, as the old adage goes, is really, really a better thing to do. And I think that's what we have to start doing. We've actually deprioritized innovation in so much just to keep the status quo that we're so risk averse to do anything about it. And I think that's where it has to start. And I think it has to start very small, with very small projects, and then work its way out. Adrian, you got anything to add?
I think I'd just flesh out a couple of thoughts there. One is in terms of team. As I kind of alluded to this before, that in the last question, technology is not the answer. Changing the way processes work is the answer, and technology is one of the ways that change can be managed. So the first thing you need, you know, and Monica talks about having this team, this management team, it needs to be a cross-functional team brought into the notion of change. And again, back to cultural issues, one of the things that I like to point out about what we're talking about here is this is really the IT-ification of the assembly line. You walk into any plant and there's a very different, there's a wall between processes and controls and IT. And IT is very much a supporting function that enables a lot of times networking and communications between devices. But as you start to gather this data, as you start to take a more system-wide view and a new kind of meta lean attitude to improvement, then all that stuff happens up at a pretty high level in the information stack, and that's out there in IT. So, you know, how do you get started on these projects? A cross-functional team. It might be controls, it might be quality, but it has to be IT as well. That has to be a function that's in there from the start. And then, yeah, start small, grow big. I mean, short-term projects and long-term plans. That's the way it works out. If you can't show a quick win with these types of changes, then the whole organization rapidly loses interest in pursuing it. Even though your grand vision of the future might be perfect. You can't get there in one step. You've got to get there in a bunch of smaller steps, and every one of those had better add value. So it's long-term vision, short-term plan, and a cross-functional team that's all bought into change.
Okay, Adrian.
And I'd like to add, I'd like to add one thing too, when you're doing with this cross-functional team, and that is the fact that, you know, IT domain traditionally has been handling transactional information, right? And what I often see is when somebody starts to do IoT or IOE, is that they make quality the responsibility of IT. That really should be at the operational level. The operational people that are seeing stuff in real time. Quality should never be at the transactional level. And until we get that dichotomy where we push that quality down into that real time level, I think that, you know, many IoT, IoE projects will fail. So that's another important part of that cross-functional team. Okay, Christine.
No, that's great. We've got time for one more question that's just come in. So open to obviously the floor here. You discussed the topic to exit the point-to-point production. Which consequences can you estimate regarding the car body shops, thinking of the enormous automation level?
So that's interesting, yes. And I think it's funny because, you know, just in my every day, people ask, you know, what my job is and where do I go? And I talk about automotive assembly, and then people picture legions of robots building cars. And I have to explain to them there are actually legions of people assembling them. So I think, it just from my perspective, you might have a different view, Monica, but the body shop to me is an entirely different set of processes than assembly. And the amount of variability in body shop is absolutely increasing. but not the exponential explosion of complexity that you see on the assembly line. So just for my part, I would see body shop, a lot of what we've been talking about here is kind of body in white onwards to finished vehicle. And simply because of the one aspect that we've talked about a couple of times here is that a lot of these concepts are all around people and thinking and how people do their jobs rather than kind of low-level machine-to-machine concepts. But Monica, I don't know if you have a different view on that, but I see the very strict demarcation between body shop and assembly line.
I think there's a strict demarcation there. I still think that there's the potential there to change things. And that's because often I will see processes in that realm that actually are duplicated once at the beginning of the line and once at the end of the line. Why do we duplicate those processes? Is there a better way to kind of put those forth? Aside from processes that need to be, like paint, that need to be like done one right after the other, like you have to spray the car in a specific, or the panels in a specific order. And really, I consider that an entire operation when I look at it systemically. There are places where we could start to change the thought process. And so maybe being unidirectional is not the way forward. Maybe there's ways to insert that thinking from assembly in there. The industry is kind of at a crux right now. It's hard to say whether that particular place will become more complex or less complex as we move forward, particularly when you start to talk about autonomous vehicles. But it is a really interesting point. I think that's about all I can add to that, to Adrian's statement there.
That's great, Monica. Thank you very much. So I'm afraid we're going to have to stop there, but obviously any other questions that come in, please keep sending them to us. And we will, of course, answer them for you and circulate to everybody who's been on the call today. So it just leaves me to say thank you all for attending. You will be sent a very short survey on your experience today with the opportunity to discuss your needs further with us. It will only take a few seconds, so please do complete it. We would really appreciate your feedback. And therefore, it's goodbye from all of us here.